Okay, so the Young's double slit experiment was so this is the Young's double slit experiment. We have the two slits, okay, and we are passing a plane wavefronts through the slits. Okay, so as we know that from Huygen's principle, each point on the slit will produce the secondary point source of spherical waves. Okay, so that waves, and here's I have the final screen. Okay, let this be the center. I'm calling it as O, and we will consider a point in the first slit and a point in the second slit. I'll call it as A point and this as B. Okay, so there's a light. So this point source is producing a light in spherical wavefronts. So from that spherical wavefronts, I'll consider a single light which is hitting a point P on the final screen. Similarly, this point is also spreading out its light in three-dimensional spherical wavefronts, and from those wavefronts, one of the light is getting hit the same point where A did. Okay, so the wave from here, wave from source A and wave from source B. Now we'll get to know the importance of principle of superposition. Young's used the principle of superposition to explain the interference pattern on the final screen. So for that purpose, we have to find out the path. So the path from BP minus AP, if this path difference between these two light waves is coming out to be lambda, we will be getting a bright spot there. Bright spot, or we can say the constructive interference will undergo there. Why? On which basis I am stating that? I'll explain you. So this thing in here is the path difference between the wave, this one and this one. This is the path difference. When the path difference between the ray BP and AP is lambda, we are getting constructive interference. So to explain that, we have to use the concept of superposition. Okay, principle of superposition. According to the principle of superposition, if you get top of a wave and the other wave is also having the top, then these two top and top will interfere, will get superimposed, and the resultant is going to be, if this is having amplitude A and this is having amplitude A, but the resultant wave will have the amplitude 2A, because they are trying to go in the same direction. So what I mean by path difference lambda is that if you have, suppose at this particular position, this ray has traveled lambda and this ray has traveled 2 lambda. It means when they reach on the final screen at point P, it has completed its 1 lambda, so it will be at its top, and this ray 2 has completed its 2 lambda, matlab it will also be on its top. So they will both having top and top, so that's why they'll give you a constructive interference. That's why we have studied the constructive superposition to explain the constructive interference. Similarly, suppose if you'll get a point on a fine screen where this is 2 lambda and this ray will be 3 lambda. So 2 lambda, 3 lambda, 2 lambda means it will be on its top, 3 lambda means this ray will also be on its top. Again we will be getting constructive. So but before reaching from 2 lambda to 3 lambda, there is some space, okay, there is some space on the final screen where you can't get a round figured value of lambda. You will be getting 0.5 lambda or 1.5 lambda or 2.5 lambdas. At that particular position you will be seeing destructive interference. To generalize the condition, I'll write here as n lambda. So this is the condition for constructive interference. Whenever there is a path difference between these two rays and that path difference is the integer multiple of lambda, then you can have a constructive interference where n can take values 0, 1, 2, 3 likewise. Where we can have the path difference 0? At the center here. The ray from A will travel some distance and the ray from B will travel some distance. You see the distance traveled by A to reach the point O on the final screen and the distance traveled by the B to reach the point O on the final screen will be exactly same. So it means that at the center of the final screen you are getting a bright fringe, and slowly at the second likewise a bright, then you will be getting a dark. Now we'll see what is the condition like we have expressed mathematically the condition for the constructive interference. Similarly we'll express a condition for destructive interference. So you can guess now. You see P, the path difference BP minus AP should be n minus 1 by 2. This is the condition for destructive interference. So how come you'll see now? You see, similarly, n can take values 0, 1, 2, 3, 4. So if we take n equal to 0, it will be lambda by 2. It can be plus or minus, and this sign doesn't matter. Can have plus or minus anything. Okay, the number. So here we'll be taking plus. So the path difference wherever you are having on the final screen, suppose we'll take a point on this point P, the ray 1 has traveled lambda distance to reach the point P, and the ray 2 has traveled 1.5 lambda to reach the point P. So what kind of physical what kind of shapes, whether the will be getting both as top on the point P or what, we'll see now. Suppose so lambda, it has traveled a lambda distance, matlab the ray is starting from its top, so it will end on its top or at point P, matlab it will be like this at point P. Now the second ray has traveled 1.5 lambda, means its lambda will be at the top, but as it's travel 0.5 lambda, its position when it hits the point P, its position will be down. The wave will be moving down, and the wave, this A from the ray which got from A is moving upward, and the ray which is coming from B is downward. Why? Because the lambda because the path difference is 0.5, matlab lambda by 2. So that's why the final will be nil. We know how do you know that the final is going to be nil? Because we have studied in the principle of superposition, destructive superposition will occur. How? This has lambda amplitude A and this is having amplitude minus A. The resultant amplitude or the resultant amplitude is going to be 0. Why? Because A minus A will get cancelled out. That's how we'll be getting no amplitude. No amplitude means what? No light. So there will be a dark fringe there. Got it? So this is how Young's explained the interference phenomena by using principle of superposition. If you are using the principle of superposition, that thing on which you are using the principle of superposition, that thing should have the wave nature on it. So that's how we have proved light have the wave nature. So there's a peculiar thing which we can notice in here. There's an interesting fact. Suppose if we consider light as bullet from source A, I'm talking about the destructive condition. One bullet from source A and other bullet from source B is meeting at some point P and giving you no bullet. It means destructive interference. So with the help of the concept, so there's a one bullet plus other bullet and giving you nothing. So that's why we can't explain the interference phenomena by using the particle nature of light. Okay, but if you see, if you take the top of the wave, bottom of the wave, that will give you a zero amplitude. If you take the top of the wave, again top of the wave, it will give you a big top. So that's why we are denying the particle nature of light. Now we'll find out the path difference between these two rays with the help of the geometry of the figure. And with that path difference, we can find out the phase difference, and with the help of the phase difference and the path difference, we can find out so many other things also. That is the beauty, like slowly once you know a concept, using that thing slowly you can do so many other things also. Okay, so now we will find out the path difference. This is my slit 1 and slit 2. Here I have the suppose the distance between these two slits is D. The distance between these two slits is D. Just for there's a angle theta it is making, and exactly parallel to this I have another one. This is also making theta, one wave, and the other wave also having theta from this slit, the other slits. So actually you see this ray from slit 1 and this ray from slit 2, they are exactly parallel to each other. So two parallel rays won't meet each other, they will meet but at infinity. Okay, so I want to see the interference pattern with the help of due to these two rays. So what I do is I use some lens in here. This lens will merge these two rays and we can see the interference pattern due to these two rays. Okay, so now we are finding the path difference. So to find out the path difference, the extra distance traveled by the ray 2 is going to be this distance. That is what we have to find out. Okay, using the geometry of the figure. You see, if this is theta, then this can also be theta. How? Because this is 90 and this is also 90 and this is also 90. So 90 and 90, this is theta, that's how this can be theta. Okay, now from this triangle we can write the path difference, this thing, the path difference can be written as d sine theta. Okay, and from this path difference we know the relation between the phase difference and path difference. The phase difference, denoting it with delta 2 pi lambda into path difference. This is the relation between path difference and a phase difference of a wave. So to get the phase difference of the wave, I am trying to find out the phase difference between these two light rays. That phase difference is 2 pi by lambda d sine theta. So now I want to find out what should be the phase difference between two rays if I want to have the constructive interference. Should be, so the condition is that constructive interference, the condition is something like this: the path difference should be equal to n lambda. If the path difference is equals to n lambda, then we can have the constructive interference. Now substitute the path difference in there. That's how we can get to know what should be the phase difference if you want to have the constructive interference. And lambda. So this lambda will get cancelled out. The phase difference should be phase difference should be 2 n2 pi. Okay, if the phase difference between any two rays is this n2 pi, then it is sure that you are going to get a bright spot or constructive interference there. Similarly, we can find out what should be the phase difference to have a destructive interference. Okay, you see now the condition for destructive interference is that the path difference, which is d sine theta, should be equal to n plus half into lambda. Now substitute this path difference in this equation. The phase difference for the destructive interference will be 2 pi by lambda into n plus half lambda. This lambda will get cancelled out. So this is the condition for phase difference to have a destructive interference. Okay, this is for constructive and this is for destructive. We have seen what should be the path difference to have a constructive and destructive interference. We have also seen what should be the phase difference to have a constructive and destructive superposition interference. Now